Hello ladies and gentle ladies, and welcome back to another Minecraft modding tutorial for Fabric 1.21. And in this tutorial we're going to be creating a fluid tank. So I've already gone ahead and created the block here, as you can see, and I've also created a screen for that with a slot in here. And we're going to fill up this area here with the fluid that is going to be stored inside the fluid tank. And we're also going to go ahead and render a fluid in the world. So let's go ahead and get started. So luckily fluid tanks are pretty simple. The most complex part really is going to actually be allowing a specific item inside this slot. Apart from that, it's fairly simple. The rendering is a little bit complicated, but we're not doing that in this tutorial. So we'll go ahead and get started with just creating a fluid tank. So what I will just mention, and I forgot to mention this in the inventory tutorial, is that when you break your block, you want your items to be dropped on the ground, and to do that you need to override the onState replaced method. And inside of here you just check that it's not the same block first of all, and then you check if you have the block entity. Then you just spawn the inventory using the item scatterer, and then we go ahead and call world.update comparators, which just says that any comparators looking at this block will need to go ahead and update. So that's all we need to do for that. And then it is quite important that you do call the super afterwards, because the super method here actually removes the block entity. If you don't call the super, then you'll find the block entity will still be there when you place down the next block, and then you get some really weird functionality. So you don't want to really do that. So let's go into the block entity since we're done with the block class. And all we're going to do here is basically the exact same as the inventory. So we're going to create a fluid tank. So what we're going to go ahead and do is we are going to create a single fluid storage. So let's go with a private final single fluid storage. And we're going to just call this the fluid storage. And this is just going to be equal to a new single fluid storage. Now you will see here that this tries to override the get capacity method, and that's because there isn't really a implementation of this single fluid storage. So if you go to implementations, you see the only implementations are just anonymous implementations, and these are used for vanilla as far if I remember correctly. So we don't really want to do that, and we could actually use this. We could use this with fixed capacity one. In fact, that would be perfectly fine for our circumstances, but if you don't want to have a fixed capacity, then you could look at creating your own single fluid storage class. So just a class that extends this single fluid storage and basically handles the capacity, and you could also override what you want to do when it changes and that kind of thing. I actually didn't know that existed until I looked in that class. I was going to go ahead and create a new class for this, but it turns out in that case we don't actually need to do that, since with fixed capacity will work perfectly fine for us. We don't need a non-fixed capacity because it's always going to have the same capacity. So let's use single fluid storage dot with fixed capacity, and then we're just going to give it a capacity. So the interesting thing about fluid storages, and it's the same as energy storages really, is the capacity is a long compared to, for example, in Forge, where the capacity would be an integer. So this is actually very handy, and that allows us to store a lot of fluid in here. Now the capacity that you use is completely up to you. I will just mention though, this is not like Forge in the way that fluids, a bucket is not 1,000. So a bucket is actually, we can go to fluid constants, and if you come in this class, you'll see that a bucket is 81,000. A bottle is 27,000, a block is 81,000, an ingot is 9,000, a nugget is 1,000, and a droplet is 1. So I agree, this is really weird, right? So if you want to determine how many buckets to store in here, say you wanted 10 buckets, it wouldn't just be 10,000 like in Forge, it would be 10 times 81,000, so it'd actually be 810,000. So that is a very important thing to note for this. So we are actually going to use that. So we're going to say fluid constants.bucket, and I'm going to say that I want to store maybe 50 buckets. That's actually not that much, is it? So maybe 100 buckets, sure. And then we also need to go ahead and have a runnable in here, which will be called when this fluid storage is changed, right? So if the fluid changes. And the reason this is important is because when it changes, we need to mark our block entity as dirty. And then we also need to go ahead and send an update to the clients so that they can be notified and render that new change if they have a block entity renderer or a screen that would show that. So what we need to say is we simply just need to call our update method. And I've just gone ahead and actually copied this from the previous tutorials. You can see the update method here. We just mark dirty, and then if the world is not null, then we update any listeners of this position. Okay, and you'll see that can be a method reference. So we'll just change it to a method reference. It will then be this : update. Okay, perfect. So that actually simplifies that code a lot more than I thought it would. So after that, we can go ahead and create our provider method. So if you remember, for inventories, we have to create a provider in here. So we need to do that for a fluid storage as well. So we need to say public SingleFluidStorage, or we can actually just use FluidStorage if we want to be more generic. I'll keep it kind of SingleFluidStorage. I think that's fine. And we can say get fluid tank provider. That's what I'm going to call it. It doesn't matter what you call the method really. And we're just going to pass in the direction. Now, obviously you can have this based on a direction. So you could say if the direction is direction.up, then you could give a different fluid storage than if you had direction.down, for example. So you could have different storages in different directions and that kind of thing. I'm just going to stick with this one single fluid storage here, but obviously you can create as many as you want for the different sites, and you can return them in here. So I'm not going to have this if statement. I'm just going to return this fluid storage, which will mean that for any direction, no matter what directions passed in here, it's always just going to be this fluid storage there. And likewise, as before, we need to go into our main class and make sure we register this in the onInitialize method. So we need to say fluid storage .sided, and we're going to register for block entity. We're going to say example fluid tank block entity get fluid tank provider, and then we're going to say block entity type init dot example fluid tank, and we can now define any logic. And so we're going to go ahead and do our normal if this dot world is equal null or this dot world dot is client, then we're just going to return. And we always do that because we only want to tick on the server side. Now, actually, before we go ahead and do this, we need to make sure our slot can only even accept items that have a fluid storage in them. For example, we don't want to be able to accept diamonds because diamonds don't store a fluid. So it shouldn't be able to go into our slot in the first place. So we do actually need to go ahead and do that. Luckily, that is relatively simple. So what we're going to go ahead and do is we're going to create a method that we can call to check if a specific item stack will be valid in our slot. So I'm just simply going to say public boolean is valid, and we're going to take in an item stack, and we're also going to take in an int slot. However, we're not going to do anything with the slot, so we'll just say if slot is not equal 0, then we're going to return false because it's not valid, it can't be in our inventory. Then we are going to say storage of type, and that is the one, by the way, from the transfer API. So from net.fabricmc.fabric.api.transfer.v1.storage.storage, and then that is of type fluid variant, and we're just going to call this the storage, and that is going to be equal to container item context dot with constant. We're going to pass in that item stack, and then we're going to find, and we're going to pass in fluid storage dot item. So what this will go ahead and do is it will create a item context using our stack, and the stack will be used to then go ahead and look up using the fluid storage, but specifically the item type. So basically the way that fluid storages work, and the way that most kind of Fabric lookup API stuff works, is you have a sided storage, which is for your block entities, and then you also have an item storage, which is for items. For example, you might have an item that can store a fluid, or an item that can store energy, or an item that can store items, right? That kind of thing. So that's why you have kind of fluid storage.item, and you also have energy storage.item and inventory storage.item as well. So we are using this context, which the only context we have is the stack. And we're seeing if we can find any providers that have been registered to that item. Then we're going to say if the storage is null, so if it doesn't exist, or we cannot insert into the storage. So if it does not support insertion, then we're just going to return false. Now, else, all we actually want to go ahead and do is we actually just want to return true. Since if it has a storage, we want to actually allow it. We don't care what the fluid is. We're not going to try and insert it. That doesn't matter. We're just going to go ahead and return true, which means we can actually simplify this whole entire if else here to just be a return statement. So if the storage is not null and it supports insertion, we return true. Else, we just return false. Now all we need to do inside of our inventory here, we can say is valid, which is a method we can override. And all we need to do is return example fluid tank block entity dot this dot is valid. And then we're going to pass in the stack and the slot. We also need to go ahead and change this in our screen handler here. So we are going to come up here and we are going to come into add slots. And what we actually need to do is create this as a class, and we're going to override the can insert method, and we are just going to return inventory dot is valid slot 0, and then we pass in the stack, which will basically go ahead and call this is valid method here, which in turn will call our is valid method down here. But I need to come back to this is valid method, and as you can see, it's a little bit different from what I originally coded in the tutorial here. So this if statement needs to be added at the top. So if it is an empty stack, then you just want to return true, and that's because you want to allow it to, you know, be empty, right? If you don't have this, then when you try to set it to an empty slot, it might just not accept that, and then you have all these different problems. So you need to make sure it returns true if the stack is empty. I've also found that checking whether or not the storage can be extracted or not causes an issue, because by doing that, for example, adding in an empty bucket would not work, because an empty bucket cannot be extracted from. So we need to completely get rid of that check for whether or not it supports extraction. So after we have checked that it is server side, we are going to go ahead and first check if the inventory is empty or not, and whether or not the item in the slot is valid. So let's go ahead and do that first. So if this .inventory is empty, or it is not valid for this .inventory get stack in slot 0, then we are just going to go ahead and return, since we don't want to continue. Then what we are going to go ahead and do is we are going to go ahead and get the fluid storage from the item. So let's go ahead and say storage of type fluid variant. And this is the item fluid storage. And this, we can't do the same as what we did before. So before, we were able to just use a constant of the stack. However, this time we can't do that, because if we completely empty the fluid storage, then it might want to go ahead and change into something else. For example, a lava bucket, once it's empty, would change into a normal bucket. So we can't give it a constant context, because it might not be constant, and it won't be constant in our circumstance. So what we actually need to go ahead and do is create a context that we can use. So we're going to come up to the top, and just below the inventory storage, we're going to create a private final container item context, and I'm just going to call this the fluid item context. And I'm going to set that equal to container item context dot of single slot. And all we need to do is pass in this .inventory storage .get slot of the index 0. And then we can just go ahead and use that inside of our tick method. So this .fluid item context .find FluidStorage.item. And that should now be able to be modified if it needs to change it into just a normal bucket, for example. Then we are just going to do a null check to check that this is not null. This should never happen because our isValid method should be able to handle that. However, just in case, because you never know what could have gone wrong there, so we're just going to say if item fluid storage is equal null, then we're just going to return, and that will also get rid of any little warnings that IntelliJ will give us about it being null. Then what we are going to go ahead and do is we're going to try and find the fluid variant that will be allowed to be inserted. So we're going to go ahead basically through all of the possible fluid variants stored in this item, and we're going to find one that is going to be allowed. So I'm going to create a fluid variant, and I'm just going to call this the match. And I'm going to set that equal to null by default. Then what we're going to do is we're going to loop through all of the fluid storages. So we're going to say fluid item fluid storage dot non-empty views, and then we're going to say .for, which will turn that into a for each loop. And I'm going to call that a storage view. And we're going to say if storage view dot is resource blank, then we're just going to continue. Then we're going to try, and we're going to create a transaction. So transaction is equal transaction dot open outer, and we're going to simulate an insertion into our fluid storage of whatever resource is stored inside this storage view. So we're just going to say if this dot fluid storage dot insert, and we're going to pass in the storage view dot get resource. Then we're going to pass in fluid constants dot bucket, since we want to be able to try and insert a bucket or not. So we're going to say fluid constants dot bucket. In this circumstance, we could just say 1 if we can insert one of this resource or not. However, we're going to try with a bucket. We might as well. It doesn't really matter because we're going to be checking if it's greater than 0 anyways, not if it's greater than or equal to a bucket. We're just going to check if it's greater than 0. We could do 1, we could do bucket, it doesn't matter. So we can then do passing in the transaction, and we can check if that's greater than 0. Now, if that is greater than 0, we're just going to set match equal to the storage view dot get resource. And then we will go ahead and break. Then what we're going to do down here is we're going to say if match is equal null or the match is blank, then we're just going to return, since we don't want to try and deal with doing anything if that's the case. Okay, then we're going to create a new transaction, and this one is actually going to be the one that actually inserts and extracts the resource. So we're going to say try transaction is equal transaction dot open outer. Then we are going to say, then we are first going to try and insert it into our fluid storage. So we're going to try and insert a bucket's worth. So we're going to say long inserted is equal this dot fluid storage dot insert. We are going to insert the match. Then we're going to insert a bucket's worth. So fluid constants dot bucket. Then we are going to pass in the transaction. Then we are going to try and extract the inserted amount. So we're going to say long extracted is equal the item fluid storage dot extract. We're once again going to extract the match, and we're going to set the maximum amount to extract as the amount that was inserted. And then we're going to pass in the transaction. Then we're going to say if the extracted is less than the amount that we're trying to insert, which is a bucket, then we need to go ahead and we need to take that back out of our storage. Otherwise, we will be getting more than possibly is actually stored in the item storage. So we need to say long extra is going to be equal to fluid constants dot bucket negative the extracted amount. Then all we have to say is this dot fluid storage dot extract, and we're going to extract the match once again. We're going to extract the extra amount and then the transaction, and this will just take away any extra fluid that we don't want to have. Then we are just going to call transaction.commit, since we want this transaction to actually take place and not just pretend to happen. Now, since we're not going to be rendering the fluid in this tutorial, we are going to just create a simple debug message in the log that will tell us the stored fluid and also the amount that is stored. So all I'm going to say is I'm going to say tutorial mod.logger. I'm going to say .info. I'm going to say the fluid, which will be there, and then I'm going to say the amount afterwards. And for the fluid, we're going to use this .fluidstorage.get resource, and ideally we want some reasonable kind of name. So let's get the registry entry, and then let's get the ID as a string. That'll give us a somewhat readable name. It's not going to be player readable, but it will be readable enough to tell what it actually is. It will just be the identifier of the fluid. Then finally, for the amount, that's just going to be this .fluidstorage.get amount. The final thing that we need to go ahead and do is we need to go ahead and read and write this to the NBT. So first we are going to go ahead and write the NBT. So we're going to use this .fluidstorage and we are going to write the NBT. So we are first going to pass in the NBT. Then we are going to go ahead and pass in the registry lookup. And then we can do the read NBT. So we can say this .fluidstorage.read NBT from the NBT and the registry lookup. Now this will work, generally this will probably work, however this kind of gives us a little bit of a problem because we're reading the NBT and the inventories directly from the NBT tag right here. So this means that if either of these were to share a name that they saved it to, then that would cause us an issue. So that's not really going to work how we want it to. So what we actually need to do is go ahead and get a specific compound that will save these specific storages in. So what I'm going to say for the write NBT is I'm going to create a new compound. So I'm going to say var inventory NBT is equal to a new NBT compound. And then I'm going to write the NBT of the inventory to that compound. And then what I'm going to go ahead and do is I'm going to say NBT.put. I'm going to put the inventory and I'm going to pass the inventory NBT into that. Then I'm just going to do the exact same thing for the fluid storage. So fluid NBT is equal to a new NBT compound. Then I'm going to pass the fluid NBT into the write method. And then I'm going to say NBT.put fluid tank. And I'm going to pass in the fluid NBT. Then in the read method, we need to change how this works. So first of all, we can do a condition to check if these actually exist. So we can say if NBT.contains, if it contains an inventory of NBT element.compound type, then we can read the NBT from NBT.getCompound of name inventory. Then for the fluid storage, this will be the same. So if NBT.contains fluid tank of type NBT element.compound type, then we can say NBT.getCompound of fluid tank. And that will mean that we're not going to have any collisions with any of this. And that shouldn't cause us any problems now, where it probably would have before. And the important thing to note as well is that we are syncing this to the client here. So we are using write NBT to sync that to the client. So when we do our block entity renderer, that's how we're going to get the fluid to show up, because this is also automatically being synced to the client there. So now all we need to go ahead and do is we need to run the game, and we need to also make sure you've run your data gen. So if we right click our block and we place a lava bucket in there, you'll see that the lava is taken away. It's converted to a normal bucket, and in the console down here, you can see that the fluid is lava with an amount of 81,000. And you see if I try to place a water bucket in there, that does not do anything, of course, because it can't put water in there because there's already lava in there. And obviously an empty bucket doesn't do anything either. And if we try to put some random item in there, I can't. I can't show you that I can't because that's not going to work, but I can't do that. So as you see, if I put some more lava buckets in there, those are going to go ahead and increase that amount. It's now 162. And if we put another one in there, 243, 324, 405, 486, 567, 648, 729, 810, 891, etc., etc. And you'd be able to do that up to 100 buckets, which is what we specified in the block entity up here. Now obviously this doesn't render in the GUI, and more importantly it doesn't really render in the world, so it's not very helpful really, and that is why we're going to be doing those things in the next two tutorials. Another thing that we can quickly go ahead and test whilst we're here is if we place an item in the storage and then break the block, it does indeed drop the item that was stored in there. So that's great as well. That is it for this tutorial. I hope you found it useful. If you did, please do be sure to give it a like and subscribe. If you have any issues, feel free to join the Discord, which is linked in the description down below. And I will see you in the next tutorial. Goodbye.